Hello dear student, you are welcome to my video lectures. This is Professor Ashok Kumar. I welcome you again. I am working in Department of Mechanical Engineering at Dr. Subhash Technical Campus. So this is the last lecture through which we are going to discuss the remaining portion of the chapter number 1, Introduction of Mechanism and Machines. So up to now, through my previous two video lecture, we have discussed a lot about same chapter. We have discussed especially one machine, its types, mechanism and its type. We have also discussed about the various types of kinematic chains, kinematic pairs, and of course we have also discussed a lot on especially inversion of mechanism. So by continuing that remaining types of inversion of mechanism, we will discuss entirely in this lecture all the remaining mechanisms during these lectures. Look at the diagram that first you have given the mechanism like reciprocating engine mechanism. Basically, it is the simplest form of a slider crank mechanism, so that by fixing any link of a slider crank mechanism you can have the reciprocating engine mechanism. And one can easily see from the figure that basically there are 4 links. One is frame, that is fixing frame number 1 to 4, that is the fixed link or say the frame. Second one is the crank, A to B and B to C, that is the connecting rod, and ultimately there is a crosshead or say the piston which is located at point C. So this is how the 4 links or say the 4 different links are to be connected in case of reciprocating engine mechanism. By looking carefully you can also search that there are basically out of 4 linkages, 3 linkages having the turning pair, whereas only one pair that is of the sliding pair of piston that you have given. So ultimately 3 turning pair and 1 sliding pair the reciprocating engine mechanism has. Basically this kind of the inversion or say the reciprocating engine mechanism is used in IC engine, or there are numbers of we can say that machinery and automobile vehicle to which we are using the reciprocating engine mechanism. So prime objective of this type of reciprocating engine mechanism is to convert the rotary motion or say the reciprocating motion into rotary motion. But because ultimately we require to convert the reciprocating motion of piston into rotary motion of crankshafts, and that we need at the end as a mechanical power. So this engine, by using this engine you can have the conversion of motion from reciprocating motion of piston to rotary motion of crank. After that one more inversion is there, and that is we can say that gnome engine or rotary engine, and it is basically the inversion which is made from the single slider crank chain mechanism. And if you are looking this diagram that you have given, the gnome engine is generally rotary engine, V shape, or we can say that the V type internal combustion engine, and before few years it was used in aero engine, but presently due to its efficient operation this type of engines have become obsolete because it is nowadays it is totally replaced due to modern inversions of the mechanisms. So if you are talking about the gnome engine, then especially link 2 is fixed and link 3 is the work as a driving link, whereas link 4 we can say that work as a piston or say the piston and cylinder assembly is there. So complete assembly of the cylinder and crankcase will rotate about the fixed point or central point, you can see that, and by doing so you can have the reciprocating motion of the each and every piston which are arranged on the peripheral surface of the entire engine. So the gnome engine or say the rotary engine, also the prime function of the engine is also to we can say that the convert rotary motion of crank into reciprocate, or vice versa you can have also. So basically, if you are using the same mechanism for the we can say that the propelled vehicle like automobile, then the prime goal of this engine will become to convert the reciprocating motion into rotary motion of crank. Third type of the mechanism, that is Whitworth quick return motion mechanism, that we are going to discuss. Especially if you are talking about the mechanism, it is widely used in specific workshop machinery like shaper machine, in which specially this type of mechanism is used. In this mechanism, generally driving link is always rotated with angular velocity, and it is connected with the slider directly. So whenever we can say that the crank is rotating with uniform angular velocity, slider will reciprocate inside the slotted link, which causes slotted link to oscillate above the pivot. So in that we can have the motion transmission. First of all, link will rotate and link is directly connected with slider. So a slider actually reciprocate inside the slotted link. Now if you are thinking and observing clearly the diagram, again the slider is connected with the point R, that means ram. So whenever you are rotating or you are supplying the motion as input to the crank, ultimately the motion that is supplied to input link will be at the end will be converted and transferred to the ram. That means the ram at the end the tool is mounted there. So ultimately we can say that through Whitworth quick return mechanism, we can convert the rotary motion of say crank into reciprocating motion of a ram, because we required reciprocating motion. This is so because in case of shaper machine generally perform a flat turning operation. So for that we require the flat or say the horizontal movement of tool, and that's why the ultimate link or say the last link should perform the linear operation, or say the linear motion the last link should be have. So this kind of the application is fulfilled by using Whitworth quick return motion mechanism. One more thing about this quick return motion mechanism is that only we require during cutting operation we require the slow motion of the ram, whereas during idle stroke or say the idle operation, that means whenever ram will move from forward to backward direction, and at that time we don't require any cutting operation. So ultimate requirement of this mechanism is that cutting stroke should be performed very slowly, whereas the returning stroke should be performed very quickly. So this is fulfilled especially through Whitworth quick return motion mechanism. And the relationship for the cutting operation for achieving this kind of operation look like that. It is the ratio of time of cutting stroke upon time of return stroke, which should be always equal to angle theta and upon angle phi. Now after that there is oscillating cylinder engine. You can see the right hand side you have given a figure. It is also an example of third inversion of single slider crank chain mechanism, and which is obtained by fixing the connecting rod of the reciprocating engine mechanism. So if you are fixing the connecting rod of reciprocating engine mechanism, you are getting oscillating cylinder engine. Now piston rod and piston is like work as a rotational motion, both of the links has, and it perform the required operation. So now oscillating cylinder engine, the prime objective of this mechanism is to convert reciprocating motion into rotary motion. And similar kind of the mechanism that you are looking, and that is the hand pump. So in case of hand pump, basically there are 4 chains. So ultimately we can say that it is the 4-bar chain mechanism also hand pump has, but fixation of link will be changed. In case of hand pump, link number 4 will be fixed, and whatever the inversion or the mechanism we are getting, that will be the known as hand pump. So in case of hand pump, link 1 will reciprocate inside the piston, and we can say that the cylinder assembly. and whereas link 2 and 3 will oscillate about the pinpoint. You can see that link 2 and link 3 are connected with a common the pinpoint, and whenever you are applying force at the end of the link 2, a piston will reciprocate inside the piston and cylinder assembly. Now after that, there is an inversion of double slider kinematic chain, and of course it has two turning and two sliding pair. First inversion that we are getting from the double slider kinematic chain, that is the Scotch yoke mechanism. Generally, Scotch yoke mechanism can be easily obtained if you are fixing any one link of the double slider crank mechanism. And the basic application of the Scotch yoke mechanism is to convert rotary motion into reciprocating motion. Generally, driving crank rotates about the fixed point, and due to that rotation of the driving crank, it will reciprocate the piston which is inside mounted inside the slot or say the cylinder. So from the figure, link 2, link 3 and link 4 are connected. If you are giving a little motion or rotary motion to link 2, of course the link 3 will reciprocate inside the slotted portion which is given, and link 3 is connected to link 4. So in that way, link 4 will also reciprocate inside the piston and cylinder. After that, the second inversion from the double slider crank mechanism is Oldham's coupling. Look at the diagram. Basically, Oldham couplings is used to connect two parallel shafts when they are not coaxial and the distance between their center lines is very small. So this is the specific application of Oldham's coupling. Secondly, the two links have, say the link 1 and 3 have their flanges which is rigidly fastened to the shaft, and one intermediate piece is introduced in between them. That means we can say that the flange 1 and 3 is mounted on driving and driven shaft, whereas there will be a slot, a rectangular slot is cut on the faces of flange 1 and flange 2, and in order to connect both of that slotted flange which is mounted on driving and driven shaft, there will be an intermediate piece required to insert in between the slots of both of the flange 1 and flange 2. So that intermediate piece have the projection cut in the form of square on the both of the faces or the surfaces of the intermediate piece. But the square projection should be cut in such a way that the projection should have the we can say that the perpendicular relation or we can say that on the both of the side this projected part should have the perpendicular axis with each other. So in that way you can have the assembly of the Oldham's couplings all parts, and once you are giving the rotation to driving shaft, ultimately the driving shaft will transmit its rotation to link 1, that means flange 1, and flange 1 we know that it is connected through projection and slot to intermediate piece. So ultimately the intermediate piece will receive the rotational energy, and again intermediate piece is connected with a driven flange, and driven flange is connected with the driven shaft. So in that way you can have the motion as well as power and torque transmission from the driving shaft to the driven shaft. After that, one more inversion of mechanism from the double chain mechanism we can say that obtain, and that is the elliptical trammel. Basically, elliptical trammel, especially in which link 4 of double slider crank chain, if you are fixing it, it will be obtained. So this is an example of the fourth inversion of double slider kinematic chain, and any point on the extension of link 2 it will trace the path of an ellipse. So ultimately elliptical trammel is generally used to trace the path which is mounted, path of point which is mounted on any link. Generally such a mechanism, that's why it is used for tracing the path of various size of an ellipse. So suppose you require to have an ellipse for any ellipse to generate for any link or the points which are mounted on the link, you can have the application of an elliptical trammel. And finally, the point number 3 that we are going to discuss, that is degree of freedom. Generally, degree of freedom of any point is the numbers of independent coordinates required to define the position and orientation of point. Look at the diagram. From the diagram you can easily understand there is a cube, and in order to identify any point on that cube you require at least 3 coordinates, x, y and z. So we can say that there is a 3 degree of freedom of that point on cube has. But in case of rigid body, in order to locate the position and orientation, geometrical axis along with the rotational motion is also required to identify that point. So any point which is locating in any geometry can be easily, and we can say that very effectively identified by 6 parameter: xyz translation motion in xyz direction, whereas rotational motion on the same direction, xy and z direction. So we can say that that cube or the point on cube has the 6 degree of freedom, because in all 6 direction we can have the identification, or we can say that the determination of that particular point. Now if we are talking about spatial and we can say that the planar mechanism, then in this case spatial mechanism, the complete motion are generally not represented by a single plane. So more than one plane is required, and that's why the 3 motion of paths we required for the spatial mechanism. And this type of mechanism generally used, for example, in case of robot arm cranes, in which specially 3 degree or the 3 planes are required to complete identification of any we can say that the machine component like robot arm or the cranes. Whereas in case of planar mechanism, it is very simple mechanism, and all the motion for oblique can be represented by a single plane. That means suppose you have given any mechanism, and you can identify or you can represent all the links motion by adopting single plane. So we can say that it is the planar mechanism. In short, the mechanism which can be easily identified by using single plane, we can say that it will be the planar mechanism. And actually majority of the mechanism will be have this type of characteristics, so all that known as a planar mechanism. So dear student, this was the last lecture of first chapter, in which we have specially discussed on remaining types of inversion of mechanisms. Still you are finding any difficulty, let me inform, we have the solution. Again, thank you very much for your kind of attendance to my video lecture. Thank you very much.